This is the preliminary solar evaluation for Williamsburg Church, Group 1. Our direct client would be the board in charge of church responsibilities, but other stakeholders involved could be the members of the church and the church community as a whole. Churches are usually short on money. Coupling that with really high monthly electricity consumption makes solar a really good option and could save money on the electricity bill.
Here's our given locale for this project. The address is Williamsburg Church, located in Williamsburg, Pennsylvania. Its type of place is rural and is surrounded by loads of trees. Its placement for PV system is going to be on the roof, and the roof is a flat surface roof. Its climate regime, being in Williamsburg, Pennsylvania, is not going to be on the higher end of the amounts of sunny days, but it's definitely not too low to consider solar PV systems. Frequency of beam diffuse components, which means total solar radiation. The solar elevation for winter months is much lower than summer months in general, the, meaning that the solar PV projects in Williamsburg are not going to produce huge amounts of energy, but it's still manageable to have a PV system. And lastly, our time of horizon, which is not our focus for this homework.
The PV system, as you can see from this picture, had to be placed around the vent. This is due to the vent being on a higher elevation than the rest of the roof and not being a flat surface. Also, it causes shading onto the panels, so that had to be considered. This is why our modules are 20 degrees, tilted 20 degrees, because this number minimizes the shading from the vent and maximizes the number of panels that we can fit onto the roof, which of course is limited space. The modules also include fans for cooling to keep the efficiency high and the panels as low of a temperature as possible.
Now moving on, since we're not going over the economic analysis of the model, I decided to leave out the financial model and only include the performance model of the report. The same performance model consists of 94 Trina Solar TSM 320 PD14 modules and one inverter of type STP 2400 TOUS10. The annual results of most importance are listed from net to inverter to performance ratio right here. These results for net to inverter are 23,980 DC kilowatt hour, which go to the grid at 23,060 AC kilowatt hour by using the DC to AC capacity ratio of 1.25. The capacity factor is only 8.7, which is the fraction of the percentage amount of power produced to a maximum available. And the nominal value is usually like 10 to 25%. And the typical starting PV performance ratio is around 77%, and we're only seeing around 49%. So these values are quite low. And as you can see from the graph, the estimated values for electric system and load. Discussing the system here, having a generation of around 1750 kilowatt in January and a generation of 2400 kilowatt hour in July is quite good. The demand, though, the demand for the church for January and July respectively is 3083 kilowatt hour and 2242 kilowatt hour. Therefore, the solar design will not cover the entire need for the electricity of the building, but cost savings are still seen here in the chart